So good morning to all of you. So today we are going to discussing about Unit 5. In this Unit 5, uh, it's a very simple unit. Easily you can secure the marks. So what I told to you in the previous class, Unit 4, Unit 5 and Unit 6. These three, if you prepare well, means then you can easily answer any question, answer to any question easily, so that you can gain maybe the marks. Or and also what I am telling to you, my advice and my suggestion to you. So Unit 1, Unit 2, Unit 3 is also needed to prepare. But when compared to the units, 3 units, this is the 3 units. So these 3 units, that is Unit 4, Unit 5, and Unit 6, somewhat very simple units, so that you can easily answer for a question given maybe in a mid two or maybe in end semester examination. So, and Unit 1 and Unit 3, Unit 2 and Unit 3, in these 3 units, so we discussed various types of sensors and transducers. But here, Unit 5 and Unit 6, completely it is a control systems. These control systems actually, this will be somewhat deviated from the mechanical. That means some electronics flavor will be mingled with the mechanical. Electronics or maybe some electrical flavor will be mixed with the mechanical system. So here in this first unit, we'll go for introduction. Today, after completion of this class, you can gain knowledge on total overall Unit 5 introduction, about the introduction of Unit 5 and the classifications. What are the classifications of the control systems and elements of the control system? What are the elements in the control systems, right? So that is the thing. Then here in the syllabus of Unit 5, these are things, that is classification, classification of control system, that is open loop control system. So 1 minute, 1 minute. Sorry for disturbance. In this introduction of the elements of the control system, in this classification is there, and what are the elements of the control system? We'll discuss what are the elements of control system. And in the classification of the control system, it is classified into two types. One is a open loop control system or non-feedback control system, and another one is closed loop control system. We can also call it as a feedback control system or automatic control system. And then next here in this, we will learn in this particular unit about the concept of open loop control system and concept of a closed loop control system. What is the difference between these two, open loop and closed loop? And also different applications, different examples. We will discuss about the open loop as well as closed loop. So here I will write on the board. So here today we are going to discussing about this is the actual Unit 5 elements of control system. So my advice to all of you, better go for double click on my photo so that the screen is enlarged, so that whatever I written on the board, it is visible to you. Clearly it is visible. So go for, I advise to all the students, you go for a double click on my screen, that is video, so that the board is visible with enlarge. It will be enlarged. So it is clear to all of you. So today we are going to discussing about this, what are the elements of the control system, right? So actually the unit 5 is introduction to elements of control systems. So before we are going for a control system, elements of control system, today we are going to discussing, before that we will discuss about what is a system. So what is a system? And what is a control system? And what is a measurement system? So here, these three, you know very well what is the difference between a system, control system, and a measurement system. See here, in this system is nothing but system. It consists of several components, or maybe it comprises of several parts which are arranged in sequence or maybe assembled together, and it performs a specific function which is the output. So that is called a system. That is called a system. And what is a control system? What is a control system? Here, control system is nothing but the system we can control the output variable. We can control the output variable. So that is called a control system. The system we can, that means the output of the system we can control according to our desired output. That is called a control system. And measurement system. Measurement system means, for example, from a system we are getting the output, right? So that output variable we can measure, that is a measurable physical variable, then we can call it as a measurement system. With the help of the block diagram, I will explain clearly so that you can get a clear idea about that one. So let me explain one example. For example, take a fan, right? So fan. Fan is nothing but it consists of winding, condenser, or maybe some rod, and then wings. So all these parts are arranged in a sequence manner. Then automatically, when you on the switch, automatically it will run. That means it performs some specific function. In the fan, our household appliances fan. I am talking about the fan. So here, that is a fan is a system. Here, the fan is a system. When you give input to the system, we can get the output. That is, for example, fan. What is the input here? Fan. Right? I will tell you. I will tell you. Okay, right, Mr. Saite Raviteja. Okay, right. See, when for the fan, the input is a electrical supply. The output is correct. Current. Absolute right, Raviteja. The output is a rotation. The output is rotation. That is called a system. System means here, whenever if you give the input, we can get the output. That is called a system. For example, now we will discuss about the control system. So what is the control system here? With the help of the regulator, we can control the speed of the fan. That means we are controlling the variable. We are controlling the physical variable. That is, here the fan is rotating. Here in the regulator, there are 5 modes are there. 1, 2, 3, 4, 5. So with the help of the regulator, here the regulator is nothing but a control system, which is, that means this regulator is nothing but a device which controls the system, that is fan. Now you got the clear idea. Here the regulator is a device which controls the fan. Fan is a system. So that's why control system. Here the system is controlled, here the fan is a system controlled by a what? Regulator. Here with the, so here we have to change the regulator of the fan 1, 2, 3, 4, 5 modes. So thereby the speed of the rotation varies. That means here what we are doing, we are controlling the physical, the output quantity of a system. Here we are controlling the output, that means quantity of a fan system. So that is the speed. So according to our requirement, for example, it is a winter season, I am feeling very chill or cold, then what I have to do, unexpectedly, unfortunately, my hand goes to the regulator and thereby I will decrease the mode, that is maybe 2 from 5 to 2 or 1. For example, it is a hot season, that means a hot summer, it is summer season, then this is a, unfortunately, my hand goes to increase the mode of the fan. That means a regulator. That means according to our requirement, we will change the output of that particular system according to our desired output. That means with the help, that means here the regulator is a device which controls the system output variable. That is called a control system. Here see, measurement system means it is also a device, measurement system. It is also a device. Here the fan is there, right? It is rotating. Here, what is the variable here? Speed. Here, what is the variable here? Speed. With the help of a device, we can measure the physical variable, that is speed of a fan. Fan is a system here. So it is a measurement system. That means we can find out the speed of the rotation of the fan. Here, measurement system is nothing but a device. It is a device which is used to measure the physical variable of the speed of the, that means or speed or the rotation of the fan. That means it measures the output variable. It measures the physical variable. So we can call it as a measurement system. RPM, right? Speed in terms of RPM. So now you can get the clear idea. Now you can get. Here this control system, we can, that is, in the control system, the output is, we can set according to our desired output, maybe manually or maybe automatic. See, this control system may be automatically, without human involvement also, we can control the system. That means we control the system means we are controlling the output variable, output physical variable. So that variable is accurate variable. The result is accurate result, the output. So this control system, it's maybe a human controlled variable or automatic controlled variable. So here, what is here variable? The output from the system. The output of the system, we can control it. So next we will discuss about that. And then next, if you see, there are several examples are there. For example, take the thermometer. See, thermometer, all of you know that it measures the temperature of a body or a substance, cold body or a hot body or a substance. Here is, for example, I will take the thermometer and then I will immerse it in so and so. Maybe water is there which is boiling, or maybe I have to check the temperature of a body. So what happens here when you place or when it is in contact with the body whose temperature has to be measured, then automatically the mercury in the sensing bulb, there is a mercury is there, that mercury level rises. The mercury level rises. The mercury level rises, then automatically a scale is there which represents the temperature of the body. So now I will give you a clear idea about this one. Thermometer is nothing but a system, right? So thermometer is a system. Here it measures, here what is the input? Here what is the input for the thermometer? Input is, anybody? Right, input is heat, absolute right. Input is heat, Raviteja, correct. Input is heat and output is, I'm asking about only the system. Output is Anybody? Displacement. No, of course, maybe the displacement. Here the mercury level rises. Here, when the sensing bulb touches the body whose temperature has to be measured, it is very hot body, then automatically heat, that is the heat source, then automatically the mercury level rises. Here the input for the thermometer is heat, the output is height, height. Here the output is height, or otherwise mercury rises, mercury rises, mercury rises, or mercury displacement, right? Rises. Simply we can call as a rises, height. So height, that means mercury rises, that means rises with some particular height. So on that, a scale is there. That is a measurement system. Measurement. We are measuring the parameter temperature with the help of the scale that is transparent. So we can measure wherever the height it is stopped, that mercury level, that corresponds on the scale, whatever the reading, that is nothing but the temperature of that particular body. So like that here. In this here system is there, measurement system is there, but control is not there. Or you understand? Here the control is not there. Here the in that here the system and measurement system, but control is not there in that parameter. Control is not there in that parameter. So it is not a control system. It is simply a measurement system. So just examples I am telling to you. So now before that, I will draw the diagram so that anybody you can note down. You can note down. So system, first system. So note down. Measurement system. What I said to you now. Thermometer. Temperature or heat. See here, it is all of visible. It is visible to all of you, right? Right. Here, if you observe here the system, here the motor is a system. Here the input is electrical power, and the output is the rotation of the that is shaft, right? Here the rotation. That means here the output. What is the parameter output here? Speed, speed, rotation of the motor. That is called a system, right? What I said to you, system is it consists or it comprises of number of elements or parts or components which are arranged in a sequence manner so that it performs a specific function. So that is called a system. So here motor is nothing but a system. What we discussed in the earlier, that is fan is a system. So like that, if you going on discussing, there are several examples are there. So here the input is a electrical source and the output from the motor is a rotation. Here this rotation, here we are saying simply this motor is a system. Here the output is not affecting on the input. Here the output is not affecting on the input. That means here the output of the rotation of the motor is not our desired output. Of course, maybe the output we are getting the output. Fan without regulator is a system. Here the fan is a system. Fan without regulator is nothing but simple system. It is a simple system. That means when you give the input to the electrical source to the fan, then the output is the rotation of the fan speed, like the speed. So here that means without regulator, we can call simply fan is a system, right? Or you understand? With the help of the regulator, the fan is rotating, then we can say it is a control system. And about the measurement system. Now we'll discuss about the measurement system. Here what we discussed in the thermometer, right? So it is visible to all of you clearly. You better click on the video, double click so that the image will be enlarged, so that it is visible to all of you. Are you getting? Yes, okay, right. Right. It is clear. The words are clear. So now here the thermometer is there. Here, what is the input to the thermometer? Here we are bringing the thermometer nearer to the hot body whose temperature has to be measured. So now here the heat or the hot body, right? And the output from the thermometer is the number on the scale. That is, here we are getting the physical variable. Here with the help of this thermometer system, we are getting the physical variable directly. But here we are not getting the physical variable. We are not getting the value of the physical variable. Am I right? Or accept? Here, so that's why we can call it simply a system. But in the measurement, is the measurement system. So we have to place the thermometer nearer to the hot body or some substance whose temperature has to be measured. Thereby what happens means that the mercury in the thermometer rises. That means the height. That means here actually the output is height here from the thermometer. What we are getting, the output is height, but we are arranging a scale that is which represents the temperature on that scale. On the thermometer, one scale is there which represents the number. That number, wherever the mercury stops rises, at that particular point, we can go for reading that scale number. Just we have to read that number, or that we have to note down the, we have to record that number. That is nothing but the variable, physical variable we are measuring. So that's why we can call it as a measurement system. It is called a measurement system. So system means, what is the difference between these two? System means we are getting the output, but it is not measurable. But in the measurement system, we are measuring the variable. So now, I hope so you can get the clear idea between a system and a measurement system, the difference. So now, what about the control system? So we can now, I will discuss the control system. So you can get a clear idea about a system, control system, and a measurement system. So now I will write the control system. Right. Control system. Here now control system. All of you listen carefully. All of you listen carefully. Heating system. All of you know that heater. In household appliances, for example, take the geyser, or maybe the, for example, it is a very cold, it is a winter season, we a heating system is arranged in that particular room. For example, in some areas it is very cold. Compulsory in every house one heating system is there. So, for example, take the heating system. Heating system. So, here the input is we are setting the required temperature. We are setting the required temperature to that system. So, and then what is the output? Whatever the setted value is nothing but the output. So, whatever here we are setting the input to that particular system, we need the temperature, maybe it is very cold, we need the temperature in that particular room is 32 degrees centigrade. You are setting with the help of the remote for that particular heating system. So then automatically the output is also a same temperature. That is, whatever you setted, whatever the required temperature in that particular room you are setting, so that is nothing but the input, and the output should be the temperature, whatever you setted value, that is the uh, that is temperature. That means this is nothing but a control system. That means control system means whatever the output quantity is affecting on the input. That means with the help of the input only, we are getting our desired output. So for example, take the AC system. So here the remote is nothing but a control system. Remote is nothing but a household appliances. So nowadays all members, that means all houses having ACs. So now in the summer season when you came to house, so there it is very too hot outside and inside also. Then you can go automatically. You can on the AC switch, and then you have to set the value maybe 18 degrees centigrade. So whatever you given input 18 degrees centigrade to AC, for example, consider this is AC, we have to set the temperature same. You are setting the required temperature 18 degrees centigrade. So the output also after some particular time, maybe 5 minutes or 10 minutes, total the entire room should be with the temperature. Now you understand. That means here the output, so you need the output 18 degrees centigrade in that particular room. So in the input only, you are giving the required temperature. You are giving the required temperature. You are giving the required temperature. So here in this control system, we can get the value that is finest value, it is accurate value. So for that purpose only, we will go for control systems. Nowadays, this control system is widely used. That means it may be in the manufacturing industries, maybe in the processing industries, and maybe in the robotics, and maybe in some other, for example, ATM, automatic teller machine, or ATM, you are taking money, that is automatic controlling machine, right? So here, like this, there are several examples, or there even woven our household washing machine. So these are all automatically control systems. Take the washing machine, for example. What we are doing, we are giving input, that is, we are placing the dust clothes into the drum. So, and then we have to close the door. And then that is one factor, one variable factor, that is input. And another input is we are we are pouring some, what is that, washing. Maybe in the, it is maybe a liquid or a powder. And then we have to close, and then we have to give whatever the output. The next step is you have to set in such a way that here 3 modes are there in this: slow rinsing and medium rinsing and fast rinsing. Whatever you required, you can go for that input mode. The output also same in that mode. Means we can, that means controlling. So for example, take ATM machine. It is a control system, automatic control system. So whatever you needed the amount, if you type automatically, the machine will give to you. For example, 1,000 rupees you need. So it will give only 1,000 rupees. For example, 2,000, it will give 2,000. That means, so here you are giving the input in ATM machine. Input, you need 2,000 rupees. But the output is also 2,000 rupees. So here same. So whatever you set the input, the output should be the setted value. Whatever you set the value, that is the output. So that is called control system. Here, day by day, the technology is going on. Always, we are depending on the control system. Take the TV, for example, in the previous olden days. For example, 15 years back, If the TV is there in the house, the person has to go nearer to the TV and then he has to switch on the TV, right? Nowadays, no need. A control system is there, remote control system. With the help of the remote, some particular distance it will operate. So just you can on, so the TV will on. So like that. Even AC or maybe some other, even in cell phone also, we can go for install, maybe on and off, whatever may be the device, maybe AC or maybe TV or maybe some other washing machine like that. So this is, so now we will discuss about the classification, correct? Another 15 minutes more time is there. So I will discuss another one more topic, the classification. Classification. Now we have to go for the classification of control systems. Classification. It's a very, very important compulsory question, maybe in mid or maybe in the end semester examination. Here in this unit, especially, two are there. One is open loop control system, another one is closed loop control system. In that, we will discuss in the open loop for some examples, and closed loop, we will discuss more examples. Classification. If you go for classification, there are two types are there. One is open loop control system, and another one is closed loop control system. First one is open loop control system, and another one is closed loop control system. Right. This open loop control system, we can also call it as a non-feedback control system. Non-feedback. That means here in this, there is no feedback arrangement. In the closed loop control system, we can also call it as feedback control system. Can also call it as a feedback control. Here in this control system, what I said to you that some electronics flavor is involved in this. In automatic control system, electronics flavor is mixed into the mechanical system so that we can get the desired output. So here, when you go to the other disciplines, orientation with the other disciplines, that is a mechanical system is mixed with the other flavors of disciplines, then automatically we can get the output, accurate output value, right? That is the finest value. So without any error. So feedback control system, without any error, how can you say error? How can you say error? Whatever you are not satisfied with the output, then it is error. If you are not satisfied with the output of the system, then error it is. Or error may be that system is not reached to your desired output. Right. So 1 minute, no? 1 minute. Okay, right. Here in this, in the open loop control system, it is a non-feedback control system. That means the output is not the desired output. That means the output quantity is not affecting on the input. And whereas in the closed loop control system, the output variable is affecting on the input variable. That means it is affecting on the input variable, thereby we can get our desired output. So we can also call it as a feedback control system or automatic control system. So now we'll discuss about the open loop control system, right? So maybe tomorrow I will discuss the closed loop clearly. Today we will discuss about the open loop. All of you write. So figure here see this just only two or three sentences I will discuss. Already we discussed. This is nothing but a simple system. What we discussed in the earlier. Open loop system. Here we are giving a open loop system an input, and then we are getting the output. That means the output physical variable is not affecting on the input. And one example again. Here another one. Here the output physical whatever the output variable is changing. The output variable, physical variable varies by varying the input. Now you got it. Here, that means, for example, if there is any external disturbances, maybe temperature or maybe humidity or maybe some other disturbances, if creates automatically the input changes, thereby the output is also changed. That means we cannot get the output in a correct value. And also, it will fluctuate whenever the input changes. I understand. This that means due to some external disturbances, maybe it varies. Maybe the output varies. Maybe the output varies. That is due to maybe the temperature, maybe the humidity, or maybe some other noise disturbances, or maybe some other. So, but means here the what we are getting here, the output is not the desired output. Here the output is not affecting on the input, but the output variable is varying by varying the input. That means due to some external disturbances, maybe the temperature, maybe the humidity, or maybe some other. So now you got the idea, right? So now here, this is a non-feedback element. Here in this, there is no feedback. There is no feedback means what is the meaning of feedback? Feedback means, for example, take the feedback. Feedback means, for example, I am delivering the lecture. You are giving the feedback. Means, so here, whether you are understanding or whether you are following or the explanation is good or wrong, this is nothing but feedback. So here, similarly, here also, so the output, the variable, if it is not the desired one, then it goes to the feedback. But here in the feedback element is not there, the open system. So here the open system, actually we cannot get the accurate value. And then in this, the physical, it is nothing but a physical system. It does not automatically corrects the variation in the output. So the output, what we are doing, we discussed in the previous, the output quantity or the physical variable varies by varying the input, which is some external disturbances. But here, it does this output, for example, even though the input changes, the output is also changes, but it does not automatically control. Does not automatically. Here in this examples, there are what I said that a fan without regulator is a system, that is an open loop system. And then for this, it is very simple in construction. And the main disadvantages is that means we cannot get our required output. And then here in this, there is no feedback element. Time is over. Right. Okay. Right. I will take that attendance. And next, the disadvantages. The output will change due to some external disturbances. Right. Right. Now I will take the attendance. Respond one by one. Here today, of course, maybe okay, right? Today more strength. I will take the attendance. So all of you respond one by one. One minute. So again, we are having class at 12:15. I will close. Only 1 minute left, right? So I will take the attendance. Ask me. So respond in the chat box one by one. Respond in the chat box, right? So I will ask one by one. Yes. Number one, 18th batch 320 and 81. 18th batch 320 and 81. Okay, right. 381 present, 320. Okay, okay, right. And number lateral entry and one regular one, regular one. Option right. Two right, three fast number. Three, five, five, six, six, seven, eight. Okay, six present, seven present, eight, five present. Okay, nine, 10, 9, 10, 10, 10 absent. Okay, 6 present, 10, 11, 11, 11, 12, 13, 14. Okay, 8 present, 12, 13, 13. 7 is also present, okay. 11 present, 12, 13, 14, 13 present, okay, right. 14, 14 absent, 15, 16, 15 present, 16 present, 17, 17, 18, 19, 18, option 19, 20 present, 19 present, 20 present, 21, 21, 21 option, 22, 22, 22 option, 23, 24, 25, 24 present, 25, 25 present, 26, 27, 26 present, 27 right present, 28, 28, 29 present, 28 present, 29, 30, 31, 32, 33, 34, 35, 34 option, 35, 36, 35 option, 36 present, 37, 38, 39, 38 amount, 39 present, 38, 39 present, 40, 41, 40, right, 41 present, 42 present, 43 present, 44, 44. I'm asking about 44. 44 option, 45, 46, 45, right, 45 option, 46 present, 47 present, 48, 49, 49, 50, 51, 52, 52, right, 52, 53 present, okay, right, 54, 55, 54 option, 55 present, 56, 56, 57, 58, 59, 58 present, 59, option 60 present, 61, 59 present, okay, right, 60, 61. Then next, okay, right, 60, 61, 59 present, okay. So next we'll go for section B.